Just keep on thinking about the same refrigerator and the room. And I got the answer. I hope you all are also ready with your answer. Let me show you how it can be done. We just have to write simple equation that we got from the first law of thermodynamics. I just write the equation for you here. What the equation is, del Q is equals to del W plus dE. Del Q is the heat interaction, del W is nothing but the work done, and dE is nothing but the change in internal energy. Now, concentrate on this room. Today we will take complete room as our system, as we have to come up with the temperature of this room. You will notice that I already told you that the walls of this room are completely insulated. Means there will be no heat interaction between the system and its surroundings. I hope you are also connecting it with the adiabatic processes, because this is what will happen here. Now, concentrate here. Apart from the heat interaction, we have work done. That is what surrounding is doing on this system by supplying electricity. You also understand that this work done should be negative, as the surrounding is doing work on our system. If I write both of these values in this equation, what I'll get? I'll simply get 0 equals to minus del W plus dE. Doing the certain rearrangements, we can simply understand that del W should be equal to dE. What it means? It means that for adiabatic processes, work done should be equals to the change in internal energy. It means the room temperature should increase as the internal energy is increasing. Now, let me just remove this phrase. We already understood that what will happen in the adiabatic processes. But you should keep in mind that we have many other processes as well. We will be generating the relation for each of them one by one. For that, let me again take the simple piston cylinder device. I know it's boring, but it gives us the better understanding than compared to any example. If we are talking about the isochoric process, what we will do? We will simply put the constraint on the piston so that the piston will not move, because this is what isochoric processes mean. Now, if I supply the heat, let's say delta Q amount of heat to this system, the pressure and the temperature will increase. We know this from the prior understanding and from the prior videos. But let me just put these values in the expression for the first law again. Again, writing the same thing, del Q is equals to del W plus dE. Here, I want you to notice that del W should be 0. I simply put 0 in that place. What I'll get? I'll get del Q is equals to dE. What this means? This means that heat given to system in any isochoric process, it will increase the internal energy of that system. Now, what can I write for the heat given? I can write mCv delta T. Why I am writing so? Because m is the mass, Cv is nothing but the heat capacity of the gas inside it for constant volume, and delta T is nothing but the change in temperature. I want you to keep this expression in your mind. It is the very important expression. It says that for isochoric processes, the change in the internal energy is equal to mass times heat capacity at constant volume Cv multiplied by delta T. And also one fact to note down, that this expression can be valid for any processes. Yeah, for any process, the change in internal energy always equal to mCv delta T. Now, I'll remove the constraint and again give the heat delta Q. This time we are talking about the isobaric processes, as the heat given will try to do the work on the system, because the heat given will increase the volume of the gas and the system will do work on its surroundings. Let's say the amount of work done by the system is delta W. Again, putting the values, what I'll get? I'll get delta Q is equals to delta W plus dE. Here, delta Q, I can write it as m Cp delta T, like we did in earlier example. Here, Cp is the heat capacity at constant pressure. From the previous example, we know that change in internal energy dE can be written as mCv delta T. And work done. What could be the work done for isobaric process? If you recall, it's nothing PdV, that is P pressure multiplied by change in volume. Now, if I'll do the certain rearrangement, and as you know that we took the ideal gas, putting the values, you will observe that we'll get the expression for Cp minus Cv is equals to R. And this is again one very important fact, that the subtraction of the Cp to the Cv is nothing but the constant R, which is universal gas constant from the ideal gas. Now, the only process we are left with is isothermal process. Before going to the isothermal process, I want to mention that it is an hypothetical process. You cannot achieve isothermal process in real life, but it gives us a very good result. Let me show you what. Same beaker. Now I am heating this beaker very slowly so that I want to maintain the temperature constant. For that, I again write del Q should be equals to del W plus dE. Here, I want you to concentrate on the term dE. Why I am saying so? Because I think you all know that for isothermal process, the temperature will not change. Thus, the internal energy, which is only a function of temperature, will also not change. It means I can substitute 0 in place of dE. So we'll get very special result. What it signifies? It is signifying that heat given to any system isothermally will be converted into the work. You know, this is something that we'll observe in our heat engines. Yeah, the engines that you have in your cars, bikes, maybe in ships, work on the same principle. But as I said, that these processes, that is isothermal process, are not real process. They are hypothetical. We'll see more about the heat engines in the next video.